Welcome. Thank you for joining again for a dive into the world of mechatronics. Oftentimes, when specialists are asked what is mechatronics, instead of giving a definition, they prefer to give a description of the mechatronic system. Contrary to the variety of definitions for mechatronics, researchers have pretty much consolidated around a common description for the mechatronic system. The latter includes the following main components: mechanical system, actuators, sensors, control system, and user interface. The interactions between the components can be given graphically as a block diagram. The arrows show the direction of the flow in the system. It should be noted that typically there are two flows in the mechatronic system, of information and of energy. Mechatronic systems exist which have also a third flow, that of material. Typically, the mechanical system is the centerpiece of the mechatronic system. It provides a way for interacting with the physical surroundings and enables movement. It also provides support for the other components, much like a skeleton to a living being. The actuators are the driving force of the system. They provide forces and/or torques that set the mechanical system in motion. The biological analogy here goes to muscles. Sensors provide information regarding the state of the surrounding environment, as well as regarding internal state of the system. Therefore, sensors are the senses of the mechatronic system. The control system includes on its own a number of components, but for starters, it will be discussed as one item. The control system converts information from the sensors into actions performed from the mechanical system driven by the actuators. The decision what input sensor information corresponds to what output actuator action is made through a control program. As one may guess, the control system is the brain of the mechatronic system. Finally, the user interface enables interaction with the user. It should be noted that the users can be living creatures, typically human beings, but not obligatory, and/or artificial systems, typically other human-made systems with communication capabilities. So, having defined what is mechatronic system, let's give some examples and apply the information from the previous discussion. A lot of nowadays everyday objects are in fact mechatronic systems. One such object, for instance, is the scanner. It has a mechanical system moving the scanning head, typically composed of a tooth belt drive and linear guides. It has an actuator, typically a stepper motor which drives the mechanical system, positioning precisely the scanning head. It has sensors. These are end switches for detecting the end of stroke and for homing the scanning head, which is positioning in the beginning of the coordinate system. The scanning head itself, which is a line scan camera, is a sensor. The scanner has a control system, a dedicated controller orchestrating the scanning process. It has a user interface, both for the human operator and for interacting with a PC and/or a network of other devices. So obviously the scanner qualifies as a mechatronic system based on the definition given earlier. Sometimes the considered object is not so obviously a mechatronic system. For example, an automatic parking barrier. Somewhat surprisingly, it is also a mechatronic system. The mechanical system consists of the bar, the joint that enables the bar to move around the axis of rotation clockwise and counterclockwise, and the drive mechanism. The actuator is the motor driving the mechanical system and providing the torque for lifting and lowering the bar. There could be a variety of sensors, but most common are end switches and optical sensors for sensing if an object is going to prevent the barrier from closing. The control system monitors the process of lifting and lowering the barrier and makes decisions on the basis of the sensor's inputs and the user interface. Typically, the user interface is a button-operated ticket issuing device, but in the case of a system with a computer vision camera, the interaction does not require human input. It can be said that most automated devices nowadays qualify as mechatronic systems. The final example that will be given here is probably also the most classical one: robots. This one is so obvious that it is not going to be discussed in detail as to prove the statement that it is indeed a mechatronic system. But if you like, you can check it by yourselves the same way it was done for the scanner and the automatic parking barrier. In conclusion, let's name again the main components that constitute a mechatronic system and recall some key points. For a system to be named mechatronic, it should include a mechanical system, actuators, sensors, control system, and user interface. These main components interact with each other through flows of material, information, and energy. The system under consideration may not be mechatronic, but some or all of its components can be. In addition, the components of a mechatronic system can also be mechatronic systems. This integration of a mechatronic system into a mechatronic system can go to an arbitrary depth. Thank you for your attention. I hope that this was interesting and useful, and please do come back for the next installment, covering topics that go deeper into the design of mechatronic systems.